Yeah, it was one time for me, but then I came back to it.
I had to bring my daughter with me today. Do you care if she sits in the back quietly?
Oh, no, that's not right.
Okay.
I know.
Okay. Sampling distributions is in there. Huh. Okay, why isn't that there? Oh.
I think we should all be, I'm like on the list.
You have all your pre-requisites, like, and everything.
Done. What is it, all bachelor's classes are done? I don't know. That's why I said, putting the card before the whole forestry now, this is the
Okay.
bachelor's class, right? Yeah, this is not a.
I got when they were in my summer.
Yeah, I do too.
They were like, oh, next fall, 18, you should be able to start.
I think that in spring, I think it's spring, that's not like, you have to train like proof of your immunization, right?
Yeah.
You have to get the TB test. Yeah. So I went in and got a TB test, they did the titer, came back negative. Measles, I need my MMR. And so
Friday night.
they gave me this TB, I went back to the MMR, to get this back, like, we did your MMR.
Good.
Yeah, but because of the issues with my immunization, I was like 4 months back, so those 4 months, all those people that had So, yeah.
But then, yeah, I like, I don't know, she always gets weird when I say something. Yeah, like, I don't, it's like, okay. I'm just not gonna say anything about this one. I think that might just be like. Well, she's not my supervisor. She's just stuff with like supervised visits.
Yes, she does,
Yeah.
My concern is.
And I talked to her with her. Yeah. I mean, she made me do that one supervisor, and I'm like, I don't want to do this. And then she made me do it.
I would totally, it's like a lot of workers, if you're gonna have to do it, it might as well.
Well, if somebody else like told me,
Like,
I kept all my stuff, well, I
in my
kept it all,
experience,
my
all
book,
this
and my notes from.
a lot of people don't do that. Like, it's really, here it is, figure it out.
love you,
Which sad, but like,
You know,
it's
this is hard.
yeah.
Like we're doing like
Like, training weeks, so we'll have all the tools and then just like, what we were doing. Yeah, just like all like.
She's like ready to roll.
Because like our table, we were having like disagreement, but I was really talking through it. Yeah. And I get like, and I just work through it, regular.
It's frustrating.
Like, it's great to see, like, I'm so, like, I can always be wrong, you know, but I'm so, like, I just,
Yeah.
and I'm poor addict.
Freak out about it.
Yeah.
And that's not getting anywhere, yeah.
All right, so here we have on our calendar the 13th of June. So we're going to be talking about things having to do with the normal distribution. So we'll go over those problems that were assigned for today, and then we also have one more, two more things to talk about regarding normal distribution. And then that's going to be our last topic to talk about before the exam. So then, pardon me, Monday, we will go over that homework set. Wednesday, we will have review. And then a week from this coming Monday will be test number 2. So we'll go from there. Does anybody have any question about the schedule at all? Okay. So, we want to understand the situation for this particular subject so that we can understand how it works in the general ideas of statistics. So we ask the question, what is the purpose of statistics? It is data-driven decisions. What does that mean?
Decisions based on the data.
That's correct, but that's not telling me what it means. That's
Does
using the
it
phrase.
usual and unusual?
Okay, we want, Danielle's telling me all this stuff, but other people need to do it. So Danielle, you're done. So other people need to tell me, what is this? How do we make data-driven decisions?
Through observation.
Variable numbers
No.
that are measured and collected?
No,
Experience.
no, no. Experience and humility are over here telling us that's other stuff involved here, but when we say data-driven decisions, we're looking for one specific thing.
Oh, measurements? Number
No.
of items in a specific.
No,
What to
you already told me 3 times, Danielle. You don't need to keep
Okay,
telling
I
me.
know, I
All
just
right,
didn't know
so
if it was right or
okay.
What is she saying?
What is she saying? Well, see, it's supposed to be in your notes, right? After data-driven decisions, you have
What's usual or
something.
unusual?
Well, and then what does that
I
mean?
have numbers.
Say usual or unusual?
Unusual is 5%.
But where did that come from? Danielle?
Can I say it?
Yes.
Oh, what to expect?
What to expect, right? Yep. Okay, so when we're talking about data-driven decisions, we want to be able to know what to expect so that we can react correctly to the situation that we're in, or we can do the right thing for the customer, or whatever it means. Find the right treatment for the patient, okay? You walk into the knee surgery place and they say, hey, we're going to do a knee surgery. You would hope that they would have a reason for saying that. And that their reason would be that they think it's going to work, but they don't know. They can't. It's impossible for them to know that it's going to work. But they have to be persuaded that it's a good option for you and it's a good likelihood. They want to expect you to get better after your surgery. And so you would hope that it would be considered a usual thing. They would not be surprised if you actually got better from the surgery, okay? Now, unusual events happen 5% of the time or less. Usual would be 95% or more. Why do we want to know these things? So that we can know what to expect, so that we can make good decisions. Right? That's the point of the exercise. Why we're doing the thing. So that we can have some idea of what's going on, even though we don't actually know for sure. We will never have 100% certainty about anything because we're human beings, and yet we can get some ideas of what might happen. And then we can think, well, this is possible. And then we say, well, this is likely, or this is unusual or usual, whatever. Okay. Now, in order to do that, we were talking about probability with proportions or percentages. Okay. When we talk about proportions or percent, right? A lot of times what we're dealing with there is putting people into categories. So we would say, out of this many people, how many of them had eggs for breakfast? That would be putting people into a category. And we would describe that using a percent. That was what we talked about when we were dealing with percents earlier. Okay, but now we are talking about measurements. And when we're working on actual measurements, actual numbers of things, how many hours did you spend working on this job? What's your cholesterol level? How tall are you? How much money did you spend on athletic shoes? That would be a number. And so we often are looking at using the mean and the standard deviation to understand that. So if we're looking at the mean and the standard deviation for measurements, then it's possible for us to use the normal distribution. Which is bell-shaped. In order to understand how to use the normal distribution, we made up an artificial data set, which we call the standard normal distribution. Which uses z-scores. Can somebody tell me what is the z-score in the middle of the normal distribution? 0. Okay. So then if something is higher than the average, it's a positive z-score. Lower than the average, it's a negative z-score. Okay. We have positive numbers over here, negative numbers over here. So then, how do we know what to use for the z-scores? We have to use our table. Now, there's a couple of different places you can find the table. You can go to the textbook and you could use it there, but it's also in the resources tab. Important formulas and tables. If I click on that, I have important formulas. And I have a table, the standard normal distribution. Okay. So you can find it in the textbook, page 650, 651, or you can have it on the important formulas and tables part. Okay. Notice that we have here these numbers in the first column, and the numbers going across the top are the z-scores. This is where the z-scores are. The numbers which are actually in the table, these are the area numbers or the proportions or the percentages based on this little picture down here. So if I ask the question, what percent of the data is lower than negative 0.7 for a z-score, this would be the answer. So if I say, what's the probability of z being less than negative 0.70, I look that up on the table and I see this number, 2420. That's my answer. If it's less than, then I can directly read that number off the table. Now, if you ask the question, why do we do this? It's so that we can know what to expect. It's so that we can know what things are happening, so that we can understand the probabilities of certain events. And so that's what we're finding. When we look at these things, we're finding out what is the probability of having a data value in a certain part of the graph. Now, this is the standard normal distribution. We also have the data transformation that we have to do. this is for all normal distributions. Z is equal to the data value minus the mean divided by the standard deviation. In symbols, x minus mu over sigma. So if we have some kind of actual data, like how much money people spend on shoes, if we know the average and we know the standard deviation, then we can figure out the z-score for any data value. So then we can take that information and we can come up with percent of data or probabilities for different places on the data set. Okay? Now, as it turns out, everything that I have written up here, I wrote up here on Monday. So if you're frantically trying to copy all this down, you should just turn the page and look and say, okay, yeah, I have that right. So here it is. So then, in the homework, what you were asked to do was to find these probabilities for the different z-scores. But it was not just less than. It also included having numbers or data values between two numbers or greater than. So it's less than or greater than, or it could be between two. Those are the three different things that can happen. And then the same thing is true for just a general bell-shaped data set. You can use the data transformation and you can do the same thing. Right? So we're going to do some examples. Does anybody have a question specifically about anything right now? Okay, so let's try a few of these. Pull that off a little bit here. Move it over just a bit. Why is this not doing anything I wanted to do? I don't know. There we go. Don't know if it'll work if I make it a little bit bigger. No, it's a bit harder to do, but.
I got what you were saying. It's selling my paper. That was
Six, 7, 8, 9, 10, 11, 12. Okay. All right, check with your neighbors, see if your neighbors got the same thing as what you have here. Yeah.
Oh, yeah, it is. It's just this test, right? Because you have later than fresh and
All right, so what you should have for each of these numbers when you look them up on the table would be, if you look up 1.4, it's 0.9192. If you look up 1.56, it's 9406.
Oh, you could look at the 0 and 1.4, or can you go to like 1 and then go over 4?
No, that would be 1.04. So yeah,
That's the
1.4
mistake I
is 1.4.
Gosh, darn.
1.4 is 0.
That's the
9192. So yeah, don't do that.
yeah.
Okay. All right, any other question about where these numbers come from the table? Okay, so then if we're looking at probabilities of less than, those are directly from the table. So that's 0.9192. That's the answer. If we're looking at greater than, Abby, can you tell me what to do if it's greater than? I do. So then for this situation, I'd get 0.0594. Okay. So, Alicia Bell, can you tell me how about the in-between? Okay, the word subtract is important, okay? I'm not exactly sure what else you might have said in that process, but can you tell me what the answer is? All right, Natasha, can you tell me what that number is?
0.0214.
0.0214. So we would be subtracting these two numbers. Okay. All right, any question about those processes here? Okay, so let's do a couple more. Let's do.
Take a color for it. Don't worry. So that is there anything about what
a 2.2, right?
It is?
Negative.
Yes. So for negative 2.2, we would have 0.13 or 0.0139. For negative 1.8, we have 0.0359. All right, so once again, if you might want to check with your neighbor and see if they've got stuff that looks good for you here. All right, Alyssa Peterson, what do you got?
For what one?
The first one, yeah, number 4.
0.9047.
0.9047, which you got by subtracting.
Right.
Okay, so that's what you do if you're going between two numbers. Subtract. All right. Janann, what do you have for number 5?
0.9861.
0.9861. And for number 6?
Do I have to again?
Yep.
0.0139.
Yep. Okay. So for less than, it just comes directly from the table. For greater than, we take 1 minus the number. All right, so far. So now we're going to do the same thing with not the z-scores to start with. We're going to start with an actual data set or a made-up data set. So we'll use, sure, money spent on shoes. Now, we're going to assume that this is bell-shaped, even though I can tell you it's not. We're just going to pretend that it's bell-shaped. And we're going to say that the mean is $80 and standard deviation is going to be $27. And so then we're going to ask the question, what percent of data is greater than yeah, let's say 130. Oh, I forgot my phone. All right, Nikki, what'd you get for a z-score?
0.9678.
That's unfortunately not what I asked you. I asked you what you had for a z-score.
Oh, 1.85.
1.85.
And then the area is 0.96.
Okay, so if I'm looking at this and I have in the middle, the mean is 80, and I want percent of data which is greater than 130. Okay. And you told me that the z-score you had was 1.85. Is that correct?
Oh, I forgot to.
Good. Okay, but because this is greater than this.
1 minus 0.9678
Okay.
equals 0.0322.
Okay. So we're going to take this one step at a time here. How does this happen? We have to change our data value of 130. We have to change it into a z-score. So we take that data value, 130 minus 80 divided by 27. That gives us the number 1.85. And I'm trusting that that's more or less accurate. Okay?
Thanks for trusting me.
Notice that I had to say that I was trusting you, so that's a little bit less than actually trusting you. So then, right here, when we say, what does this mean? Percent of data greater than, so I'm looking for data values greater than this. I'm looking for this part of the graph. Whenever I do greater than with z-scores, I have to find the number from the table and then take 1 minus that number. So if I look up 1.85 and I come up with 0.9678, that's this big section here. The little part here would be 1 minus 0.9678. Now, if we ask the question, what percent is that, Nikki, what percent would I say that is?
3.2.
Okay, or even just 3%.
Okay.
Okay,
So where did you get the 0.9678 from?
from the table. 1.85 on the table. $1.85. Okay, do you know where the 1.85 came from?
Yeah, I got that. I
Okay,
did the little formula.
okay, so when you do the formula, what you're getting is a z-score. As soon as you get a z-score, you look it
So
up.
we want the other side of the z-score.
But we want the other side, so that's why we take 1 minus that number. This is the number on the table, 9678. 1 minus that number is the number we want. Why do we want the smaller number? Because the question says greater than. If the question said less than, then this would be the answer, but it says greater than. Probably. Okay. So Nikki, what do we say in terms of this? What's our understanding of this? Once we get that answer.
Unusual.
It would be unusual, yes. So then if this is true, we would be surprised to have shoes that would cost $130 or more.
So the answer is 3%?
The answer is 3%, yes. Okay, so let's do another one. Let's say I'm talking about sodium in chicken soup. And let's say it has a mean of 200 and a standard deviation of 36. What percent of the data is lower than $107? Now, this might be a little hard to see, but I'll put it up here and then I'll put some notes on here. Maybe. So say it's column 0, 0.
Oh, that's
Oh.
Yeah.
Yes.
All right, check with your neighbor, see if your neighbor has good information. All right, Abby, what do you got?
I got 0.2033.
Okay, and probably how you got that was that you found the z-score of 170 minus 200 divided by 36, which comes out to be negative 0.83. Then when you look that up on the table, you find that table number is 0.2033. And since we say lower than, then that means we just take that number as it is. That's the answer.
Or if it said move to the left, right?
Or it's said to the left, but usually when we talk about numbers, we say either less than or greater than. So.
Do you have to, because you're asking for a percent, do you have to change it to a percent, or would you accept that answer?
Well, the better answer would be 20%.
Okay.
Technically, this would be the proportion of the data. And this would be the percent.
Right.
Okay. All right, so there's stuff that we did last time. If you were, for example, doing a nutritional study and you wanted to say it's really important that chicken be lower than 170 for sodium, then you would say, okay, you need to look for that. 20% of the chicken soup out there is going to have that characteristic. Okay, so this is where your experience has to come in. In order to know what numbers are actually important, you have to know what they are doing. Is this number, this 170, is that an important number? So that has to come first, but then once you know that, then you can use these tools to figure out if you can expect that to happen very often. And here you'd say 20% of the time. All right, so. Yeah. Yes. The next thing that we're going to do is think about this in the way that most statistics is done. Most of the time, we're not trying to find percentages. Most of the time, we're given a percent that's in a particular category, and we want to try to figure it out from there. So what we have to do then is we have to work backwards. This is new stuff now. So the old stuff was z-score to percent. the new stuff is percent to z-squared. So what we have to do is think about this thing that we have here, this table, and we have to kind of change our perspective a little bit. If I were to ask this question, what z-score will be used for the bottom, and let's just say 34% of the data. So I'm asking this question, if I know the percent, how am I going to find the z-score? And you have to be careful about this as to how it works. The area numbers are inside the table. And then from the area number, you look in the first column and you look up at the top to see what that is. Okay? So if I'm looking at a graph like this, and it's a z-score, so I've got a 0 in the middle, I want the bottom 34%, or the lowest 34% of the middle. That would mean I want this section right here to be 34%. If I want that to be 34%, what decimal number am I looking for? 0.34 or 0.34. So I'm going to look on this table, I'm going to look inside the table to try to find that number 0.34. What happens when I do that? Actually, we're going to look for the closest one. We're going to look for the number inside the table that is closest, 0.34. So where would I find that?
0.3409.
This number, 3409, is the closest one that I can get. This is an area number, which is what I want. And the next question is, what z-score does that correspond to?
-0.41.
Negative 0.4, and this is in column 1. So this z-score is negative z-score of negative 0.41. That's the z-score to give me that area. Let's do another one.
So how would I word that if I was writing it in my notes? I would look for the, that 0.3409 number, like how would I?
Look for that.
In the column and the charts?
I don't know how you're going to write this down in order to make it understandable to yourself. Probably the best way is you do about a half a dozen of them, and then you know what you're talking about. But for right now, you look for the number inside the table that is closest to the area. And then you look at the first column and the top of the table to decide what is z-score.
So how do you know where to start looking? Like if it's
Okay,
below
so I'm going to ask you this question. Where do we start? With the z-table,
I
right?
understand that.
Okay, so then the second question is, what is the question asking for? The question is asking for the z-score based on the area.
Correct.
So
inside,
then area is in here.
I'm saying, yeah, the whole 2 pages with the charts, where do you, where do you?
I'm looking for this number, 0.34.
Right, so you just have to search the whole chart, and we just happen to see it.
Okay, if you think carefully about this, it's not gonna be at the top.
Oh, why not? I guess it's a mention, how would we know
Okay,
where to start?
So then when you look at these numbers, the numbers at the top are very small.
Okay.
Numbers at the bottom are larger. Okay, so if you want to say, where's 0.34? It's not going to be at the top. It's not going to be at the bottom.
So just start in the zero column and look down.
That would be a good idea.
Right or left, right?
You could. Or you could just start anywhere. This is not 34. Neither is this. This is low, this is low, this is low, this is low, this is high. It's between these two. So I'm going to look somewhere. So you don't have to start in the first column. You can look anywhere to start with. But you're just going to zero in or locate yourself wherever on the table you need to be. And then when you see that number, you say,
Guess I don't have common sense that it gets bigger as you go down.
yeah, so yeah, that works. All right, so let's try another one. I want the same kind of situation, or I want to know what z-score will give me the top 3% of the.
So if you say bottom or top, does that tell you less than or more than, or?
Yes, it does.
So bottom would be less than?
Yes.
So this one we'd be subtracting?
Well, we would have to think carefully, yes, about what we're doing, right? So, Ali Cooper, can you tell me what I'm looking for? I am not. Because 0.03 would be the top. I don't want that. Taylor, what do I want? I want to look for 0.97. Because the table always has less than numbers. And so if I want the top 3%, this would be 0.03, but the table does not give me this number. It gives me my less than number. So I'm looking for 0.97. So Taylor, where is that?
It is 1.88, is closest to 0.9.
1.88 is the closest. Yes, it is. All right. So far. So now, we don't simply want to do this for the standard normal. We just don't want z-scores. We want to do this for actual data sets. Because in statistics, generally, what we're looking for is some kind of thing about a data set. And it's very often that we're asked to look for the bottom percentage or the top percentage for an actual data set. Now, when we do that, see if I can make that happen here.
Question.
Question.
Okay. Okay, so
on the table, so the answer that's on the board is 1.88, but could we also give 1.99 as the area? Or 1.89, sorry, because it's 0.9706.
Which is closer, 9699 or 9706? 1.88 is closer. It is. Well, all right. I'm tricky. Okay, I'll take that. Okay, so when we want to use this, we want to actually use it for a data set. We need another data transformation. Okay. And that is x equals green plus z deviation. So this is how we translate from the z-score to the data value. So let's use our chicken soup example. I don't remember what I said. Mean standard deviation, 227? 30. Okay. So, if I ask the question, what data value, or what data values are in the top 3%? So now I'm looking at the chicken soup and I'm saying, I want to know where are these high sodium chicken soups. I want to know where the top 3% would be. I know the mean and the standard deviation. Based on what I just did, I know what that z-score is. The z-score is 1.88. So then I'm going to say that data value will be 200 plus 1.88 times 36. So I want you to figure out what that is. What is that actual number? So that would be so we've got 200 plus 1.88 times 36. Amber, can you tell me what that number is? 268, then more or less, right?
Oh, so we can just.
We can and we should. Right?
So what number is that one?
Okay, so then the answer then, what data values are in the top 3% would be above 268.
And how did you know that is giving you that answer?
We knew the 188 from what we had just done in the previous problem. The top 3% of data has a z-score of 1.8. So then that's why we put 1.88 in there for the z-score.
So we just have to know it's that number. We don't, here's why it is that number, and don't, it's just that's that number.
We'll do another one and see if you still have that question. So let's say I'm talking about the number of fish in a stream. And I know that the mean is 45 and the standard deviation is 11. And I ask the question, what data values are in the bottom 10%?
Back to the last question, since that one's above, and it's technically, maybe I'm thinking wrong, moving to the right, you really do that whole process goes away with this section now?
We start the process over now for this. Okay.
We'd be looking for,
So we need to find the z-score of 0.1 first.
That's correct. First step is to find the z-score for an area of 0.1. All right, Eric, you got a number?
No.
Okay.
Negative 2.3 z-score.
No.
What did she say?
If we say negative 2.3, that would be 0.01. We don't want 0.10. If we go with negative 1.28, that would give us the number that we want. So if I'm looking at the bottom 10%, I want this to be 0.10. This z-score, negative 1.28. That's the closest one I have to the 10%, which I want at the bottom. Now that I have that number, what do I do with that? I put it into my data transformation formula. So now I have x equals 45 plus negative 1.28 times 11.
so are we rounding to one whole number then?
Probably go to the 10th place for this one. No, you're right. We would be the whole number because it's numbers of fish, wouldn't it?
Yeah.
Yeah.
It's a fish.
You can't do
Number of
that.
fish in a stream.
Yeah, number of fish in a stream. So yeah, we're gonna round to a whole number here. Okay.
But we don't have to subtract that or nothing?
Okay, what we're doing, since it's a negative number, it's going to turn out okay as long as we keep that negative in the formula. It still works.
What if you were looking for the bottom and with a higher number and so then it'd be in the positive numbers, correct?
If we're talking about the top, then the z-score is positive, yes. If we're talking about the bottom, then the z-score would be. Okay. So hey, Eric, you got a number for this? No, it can't be 130 because this is 45 and you want a number lower than 45. So order of operations, we got to do the multiplication with the negative first. Or if we just put it straight in the calculator, it should work. 45 plus negative 1.28 times 11. Amanda, do you have that number? 30.92, so we'll just say it's 31.
Did you say 30 or less fish? Would that be your answer, or just 30
Yes.
fish?
Well, when we say what data values are in the bottom, then it would be, a good answer might be less than 31.
30 or less than 30. So which answer are you looking for?
I'm looking for either answer, 30 or less, or less than 31. It could be the same thing. So it doesn't matter how you say it, as long as you come up with. All right, Natasha, does that answer your question?
Nope, sorry, I got a number, sorry.
Okay, when you ask me what am I looking for, I guess I don't know what you mean.
I don't even know anymore either.
Okay, so there we go. We don't have to worry about it since neither of us are dying of curiosity right now.
30 wouldn't technically be right because then you wouldn't be rounding, right? 30.9.
Okay, if I'm asking whole numbers of fish, is 30 less than 30.92? Yes, it is. Is 31?
It's not a whole fish. You're.
Right, but what I was-
Less than fish.
What I was saying is, if I could finish, was that 30.92 rounded would be 31. If you
Yes,
put
it would.
30, that's not correct rounding from 30.92. It would be 31.
I want
Right.
less than 30.92.
If you say 31 or less, you're including 31.
Right.
31 is not, there are not 31
makes
fish,
sense.
there's less than
Okay.
31.
That does make sense.
Okay.
Okay.
For the win.
Thank you.
All right, so yeah, it's time to take our break now. So let's make that happen. If I could get this to stop doing its thing here, that'd be good. Anyway. Yes, so 414.